Hello, welcome to Engineers Mindset. Now, still on differentiation of inverse three functions, let's say we have y to be equal to cos inverse of x, and we are asked to find the y all over the x. Okay, so in the previous video, we did this for sine inverse of x. Now we're doing for cos inverse of x. So it's still the same approach. What I'll do is simply since I have cos inverse here, I need to eliminate cos. And to do that, I'll simply take the cos of both sides. Okay, so take cos of both sides. All right, so I'll simply take cos of both sides. And if I do that, I'll simply have cos y equal to cos of cos inverse of what? X. Okay, so I'll simply have cos y equals the cos of cos inverse of x. And of course, this gives me cos y to now be equal to, and from the law of indices, once I have two values having the same base and multiplying each other, I'll simply pick one of the base and add their powers together. Of course, cos here is raised to the power of 1 and cos here is to the power of minus 1. So I will simply pick cos. Since the two of them are multiplying each other, I will have cos. Okay, now here is raised to the power of 1 and here is raised to the power of minus 1. So I'll simply have minus 1, then I'll put down my x. Okay, so I have this. This gives me cos y to be equal to cos, okay, this becomes cos 1 minus 1 is 0. So this becomes cos to the power of 0 times x. Okay, so from here, I can simply have cos y simply equal to cos to the power of 0 is actually 1. Remember, any variable to the power of 0 is 1. Okay, so 1 times x simply gives me what? X. All right, so this simply means that x itself is actually what? Cos y. Okay, that simply means that x is actually cos y. And since x is cos y, it means now that x is actually what? A dependent variable. X is now dependent on the value of y. So therefore, I can now differentiate x with respect to y because x now is the direct function of y. Okay, so I can differentiate x, the x all over the y, and this will simply give me what? If I differentiate cos, I will simply have minus sine y, so which is this. And of course, minus sine y can also be written as minus sine y all over 1. Of course, whichever value or whatever value divides by 1 still remains that same value. So minus sine y over 1 still remains minus sine y. All right, so the purpose of this is actually to be able to find dy dx, but because here I have the x dy. Now taking the inverse, I will simply have dy all over the x is equal to, so whatever I do to the left hand side of the equation must be done to the right hand side. Since I took inverse here and obtained dy dx, I'll also take the inverse here, and that will simply give me minus 1 all over sine y. So let's call this equation 1. Now, this is the reason dy dx is giving us a function in y. From the question, y depends on x, so y is a function of x. So which actually means if I differentiate y with respect to x, I should have what? I should actually have y in terms of x and not y in terms of y. So I need to now what? Look for a way to eliminate y here and bring in the value of x. But to do that, recall from trig identity, okay? From trigonometric identity, we had that sine squared y plus cos squared y is actually equal to 1. Okay, so I need to find what sine y is. So that means I'm going to keep sine squared y here and send cos squared y over to this side of the equation. All right, so I'll have sine squared y to now be equal to, of course, positive sign crosses an equal to sign becomes negative. So here I will simply have 1 minus cos squared y. Okay, so this simply means to find sine y, I need to take the square root of both sides because sine here is to the power of 2. So if I take the square of both sides, I'll simply have a sine y is now equal to the square root of 1 minus cos squared y. Okay, so I simply have this. But again, these terms are in terms of y. I need to also make it in terms of x. So I will recall earlier we said, recall from here we said x is equal to cos y. Okay, so recall x equals cos y. So which means wherever I see cos y, I can simply replace the value of as what? X. And here I have cos squared y. So which means in place of cos y here, I can put in the value as x. Okay, so if I do that, I will simply have, this simply now implies that sine y itself is now the square root of 1 minus, in place of cos here, but here cos is squared. Okay, so I will simply have x all squared because cos here is squared, so it becomes x squared. So this simply gives me what? Sine y. So which means I can now rewrite my dy dx in form of, in terms of x. Okay, if we do that, let me take care of. All right, so from here now, this simply now implies that dy all over the x is now equal to minus 1 all over. So we had minus 1 all over sine y, but sine y is actually what? The square root of 1 minus x squared. So this is simply square root of 1 minus x squared. All right, so that becomes the answer to that derivative. So whenever y is equal to cos inverse of x, okay, just know that the y dx is actually what? This is actually minus 1 all over the square root of 1 minus x squared. Just know this. Whenever y is actually cos inverse of x, then the y dx is simply what? This term. Okay, so I'm going to use the second approach, just like in the first case. I will use a second approach to this, and let us see if we are going to arrive the same result. Okay, so using the second approach, I will continue from here and here. So I'll just simply pick these two. I'll simply take this side off. All right, so I will simply continue with this and this. Of course, you all know how we got to this point from. Okay, so using the second approach, already you know how we got to this point. So I will simply continue from using these two to solve. All right, so I have here, I have x is equal to, I have here x is equal to cos y. So I have x equals cos y. So this can also be written as saying cos y is actually equal to x. So I said you can also call this as simply what? Cos y equals x all over 1. This can be also called as this. So in the first video, I did a recall on the application of SOHCAHTOA to trigonometric functions. So we simply said so, okay, car, and then tua, where so simply means for sine theta equals opposite over hypotenuse. Now we are talking about cos, so we are going to make use of car. And remember, cos theta from car, here simply means C here stands for cos theta, A here stands for adjacent, so cos theta is actually adjacent all over hypotenuse. H here stands for hypotenuse, okay? So here now, y is the angle theta. So in place of theta, we are simply calling that y. So cos y is actually what? From the formula, it's simply adjacent all over hypotenuse. So I'll simply have a adjacent all over hypotenuse. So it means now that x is the adjacent arm and 1 remains the hypotenuse arm. And if that's the case, let's represent this information on a right angle triangle. So I simply have a right angle triangle. Okay, this. Let's call here A, B, and C. Let this be the angle. The angle is simply what? Y. So I have cos Y. And we said cos Y is simply adjacent. Adjacent is what? B to C. The side that is not directly facing the angle is called the adjacent arm. Meanwhile, the side that faces the angle is called the opposite arm. Okay, so BC is the adjacent and it's simply what? X. So call here X. And the hypotenuse arm remains the long arm. Hypotenuse here represents what? 1. So AC here represents 1. So we need to find what? From the y dx we obtained, the y dx will be simply minus 1 all over sine y. And what we have here is actually what? Cos y. So we need to find what is sine y. Okay, so from the law, sine is simply opposite all over hypotenuse. We know the hypotenuse, but we don't know the opposite arm. So all we need to do now is what? Employ our Pythagoras theorem and find the opposite arm. And from Pythagoras theorem, you know that simply the hypotenuse arm all squared, so AC squared is equal to the sum of the adjacent sides all squared. So we have AB squared, okay, plus BC squared. You have this. And AC squared, AC is the hypotenuse arm, and the value of AC is simply what? 1. So we simply have a 1 squared equals AB is the opposite arm which we are looking for. So simply keep it AB squared, okay, plus BC here is x. So we simply have plus x all squared. Of course, 1 squared remains 1 equals AB all squared plus what? X squared. But I need AB, which is what? The opposite arm. Simply send x squared over here. If I do that, I will simply have 1 minus x squared. Of course, positive sign crosses an equal to sign becomes negative. And that's simply equal to AB all squared. So which means I can make AB subject by simply what? Taking square root of 1 minus x squared, because AB here is squared. And that will simply give me that AB is simply the square root of 1 minus x all squared. Okay, so which means this opposite arm now is simply root 1 minus x squared. So I have this, okay? So from here now, I can actually find what? Sine. Remember, sine y will now be opposite, which is root 1 minus x squared. So we have root 1 minus x squared all over hypotenuse. Hypotenuse is 1 all over 1. So this simply implies that sine y is, of course, root 1 minus x squared divided by 1 still gives us root 1 minus x all squared. So in place of sine y here, we can simply call it root 1 minus x squared. So that actually means that the y all over the x is now equal to, from here we have minus 1 all over, in place of sine y is this, all over root 1 minus x all squared, which is the same result we obtained when we used the first approach. So whichever approach can go for it. All right, guys, I hope you find this video very helpful and interesting. Please, if you do, I would like to get your thoughts in the comment section. Please, if you're new to the channel, don't forget to hit the subscribe button to keep getting updates on content like this. Thanks, guys, and cheers. I will see you in the next video.